Hi everybody, I'm Alix Paultre, and today I am at the PCIM show with a friend of mine and friend of the show, Alex Lidow. He is a co-founder and CEO of EPC, Efficient Power Conversion. And well, isn't that what the show is about? Power conversion?
It's all about power conversion and intelligent motion.
And intelligent motion.
That's
well,
right.
People forget that part of it, you know, but you have this nice
we
Android.
don't forget about it. We got it right here.
Well, you know, and when you think about that, it really gets down to the point of precision. I mean, because power's always been around, but how precise is that power? How clean is that power? How efficient is that power becomes the big question.
Yep, that's true. And how lightweight is it? Because when you get into things like humanoid robots or satellites, it's got to be small and lightweight and efficient, of course.
Now, you've been in this business almost forever, right? And you've seen the development and the growth as we've been coming along. And wide-bandgap has far beyond the promises. We're now heavy, elbow deep into the practicalities of these core technologies. What are some of the advances that you've been developing that you have here at the show?
So we're actually announcing at the show a new product at 40 volts, a 40 volt GaN device. Now, you might say, well, you had 40 volt devices before, what's new about this? It's actually the first 40 volt device that really breaks through all the barriers with MOSFETs. It's 3x smaller than a MOSFET. Okay, and in the past generations, they were a little bit smaller than a MOSFET, not much. So now MOSFETs kind of felt safe in the territory of 40 volts and down, but now the word is out, GaN's coming for you. And our next device after this, which we'll probably later in the summer announce, is a 15 volt. So we're really going down in voltage, and it's because of some breakthrough technology.
Very cool. Now, when we were talking earlier about that, I noticed you have the 40 amp board over here, the device, and 200 amp peak, and you've got all of these areas highlighted on this Android. So you're targeting specific application spaces within the application.
So with humanoid robots, it's all about motors. There are 40 motors on a humanoid. So we've made integrated circuits as well as specialized discrete devices for each and every one of the joints. And so if you look at a humanoid robot today, probably it uses our GaN ICs in there somewhere.
Very cool.
Yeah, we have like a robot dog that's been running around, a quadruped, and it's got a lot of motors in there, and those things are where our integrated circuits are used.
Interesting, interesting. What about some of the other application spaces? I mean, obviously robotics and motors and precision control. What are some of the other application spaces that you're seeing that people are coming to you for GaN solutions?
Well, GaN is always the highest performance solution. So what we look for is the applications that require the highest performance, but also will cascade down into all the others. So just an example back to the humanoid robot. Humanoid robot is the most difficult motor drive requirement today because it has to be lightweight, it has to be very powerful, it has to be very precise, it has to
fast.
take great overloads, and it has to be able to not kill you if it's working next to you. So there are all sorts of requirements. But what's good for the humanoid robot is also good for drones, is also good for e-bikes, is also good for power tools. So you get a cascading effect. That's one whole pyramid from there. Another one is AI. AI requires an awful lot of power. We hear about nuclear power plants being converted to AI power plants, and all that. So that is an area where efficiency is absolutely incredibly important, and efficiency usually means GaN. So there are many stages. There's a high voltage AC input stage, then it goes to a 48 volt on the board stage, and then it goes from there down to the GPU itself. The 48 volt socket has been one where we have been producing product for several years, and it's safe to say if you use AI, the electrons go through our parts. But it's only been on the primary side on the 48 volt. And there's a secondary side, and that's where the 40 volt devices live. Sometimes they're GaN, sometimes they're not. But now with this new launch at PCIM, they'll always be GaN. There's just no better way to do it. Smaller, better, cheaper, everything. So that we're taking that on. Watch out, move out MOSFET, that's it, it's done. But now we're also coming out with 15 volts later this year, which will take it down to the 5-volt bus. And that's the last stronghold for those damn MOSFETs.
Well, that makes a lot of sense, because at the lower power, you've got a lot of USB stuff, you've got a lot of battery-powered stuff, you've got a lot of consumer-level stuff that
all
people...
coming from the pyramid.
Excellent
Exactly,
point.
Yeah. Laptop computers, that's a 19-volt application. Consumer products are anywhere from 3.3 volts up to, 19 volts actually. But those are all now within our frame. Whereas in the past, I think MOSFETs were very comfortable thinking they were alone there.
Well, I've been telling people it's almost at the point now where for advanced applications, silicon is almost obsolete when it comes to power devices.
I just would take the almost out of there.
But now that footprint is spreading, there are other application spaces now that used to be considered safe for silicon because it was a cheap application space that, they're not going to spend that money. But now the prices are coming down on GaN and the application spaces are opening up, giving you the opportunity.
Right, absolutely. And since GaN is a much smaller device than silicon, there's certainly opportunity to make it for less money. So it can compete on price, and we do. It certainly is much better in performance and much better in smaller footprint.
So, thanks for giving me the time at this great show. I know you're busy as heck. Have any last words for our audience?
Well, I think that, if you're in MOSFETs, get out, run, don't walk, because, we're coming for you.
Very cool. Alex, thank you so much.
You.
I really appreciate this.